This is the higher GCSE revision lesson on Pythagoras theorem. Okay, here we've got a right angle triangle. There's the right angle down there. These are the two shorter sides. The longest side, which is always the side which is opposite the right angle, is called the hypotenuse. And this one's 5. And we're going to find the area of each of the squares which have been attached to the sides of this right angle triangle. This square is 3 by 3 centimeters, so has an area of 9 centimeters squared. This one is 4 by 4, so has an area of 16 centimeters squared, and this one is 5 by 5, has an area of 25 centimeters squared. Have a look at those numbers, and hopefully you can see that 9 plus 16 equals 25. And this will happen in every right angle triangle. Draw any right angle triangle you want, work out the areas of the squares on all three sides, and the two smaller squares will always add together to give you the area of the larger square. Now, that's been written down in what we call Pythagoras theorem. That's the relationship I've just shown you written algebraically, where this represents the area of one of the small squares, this represents the area of the second small square, and this is the area of the larger square. And what we can do with Pythagoras theorem is, if we know two of the sides, we can use this connection to work out the length of the other side. So for example, in the previous right angle triangle, if you'd only known those two sides, the area of the square over here, 3 squared is 9, plus the area of the square over here, 4 squared is 16, will tell you the area of the larger square. Those two add together to make 5, so therefore the area of this square is 25. To work backwards and find out what number it was that we multiplied by itself to get an area of 25, we do square root of 25, which is 5. Here's a question. Pause the video. See if you can use Pythagoras theorem to work out the length of BC. Okay, it doesn't really matter which way around you use your letters, as long as you remember it's the shorter areas added together to give you the longer one. In this case, 10 squared plus 20 squared will tell us the area of the square on the longer side. 10 squared plus 20 squared is 500. So the area of the larger square is 500. To work backwards and see how long the square was, we square root that, which is 22.3606, and so on. An exam question will nearly always specify what to round your answer to. 3 significant figures in this case. Here's the first significant figure, here's the second, here's the third significant figure. The digit to the right of that is bigger than 5, so the 3 rounds up to 4. So 22.4 centimeters to 3 significant figures. Have a look at this one. How is this different? Pause the video if you want and have a go. Okay, hopefully you recognise that in this case, in this question, we've been told what the longer side is. It's one of the shorter sides that's missing. We can still use the same relationship though to work out the length of this side here. The area of, well, let's call this x for now. The area of this square plus the area of this square, which would be found by multiplying this length by itself if we knew it. When we add those two areas together, we get the area of this square. So 36 plus x squared is equal to 81. If I rearrange, subtract 36 from both sides, I get the area of this square must have been 45, because 45 plus 36 would give me the 81. If I square root 45, I get 6.71 centimeters to 3 significant figures. pause the video and have a go at this one. Okay, we have to find out the total length of the four sides of the rectangle and its diagonals. The four sides of the rectangle are easy. It's 52 plus 52 plus 39 plus 39. We don't know the diagonals, but because the diagonals, along with the length and the width, create a right angle triangle, we can use Pythagoras theorem to work out this length here. Again, let's call the length of the diagonal x. Then this time we know the two shorter sides, so we square those and add them together. Which is 4225. The length of the diagonal must be the square root of that, which is 65. Therefore, to answer the question, we need to add together two lots of the 52 meters, two lots of the 39, and the two lots of the diagonal, which altogether gives you 312 meters. Here's another question. Pause the video and have a go at this one. Okay, again, we know the longer side. It's one of the shorter sides that we want to find out. The shorter side is the longer side area, take away the shorter side area that we know. 13 squared take away 6 squared is 133. So therefore x is equal to the square root of 133. To three significant figures is 11.5. And one more for you to have a go at. This is a little bit different. Pause the video and try this one. Okay, as well as finding this missing length here, which I'm going to call h for height, we also have to find the area of this triangle. It's one of the shorter sides that's missing, therefore height squared is equal to the area of the square on the longer side, take away the area of the square on the shorter side. 6 squared is 36. 2 root 3 squared is 2 root 3 times by 2 root 3, which is 2 lots of root 3 times 2 lots of root 3. And when you're multiplying, you can swap your order around, and it doesn't matter. 4 times 6 is the same as 6 times 4. So I can swap this to make 2 times 2 times root 3 times root 3. And by doing that, hopefully you'll be able to see that this part multiplies together to give 4. And root 3 times root 3 is 3. So 2 root 3 squared is 12. H squared is equal to 24, so therefore h is equal to root 24. I'm going to leave my answer like that for now because of the way that I'm asked to give my final answer for the area. Okay, area is equal to base times height over 2. The base of this right angle triangle is 2 root 3. The height we've just worked out as root 24. We've got to multiply those together and then half them. Well, that 2 will cancel out with that 2 to leave us with root 3 times root 24. Root 3 times root 24 is the same as root 72, because 3 times 24 is 72. We can then split that up again into two separate square roots, but if I split it up into root 36 times by root 2, again 36 times 2 is 72, but this one is a square number, so we can square root 36, get an exact answer, 6 root 2. So the area of this triangle in the form k root 2 is 6 root 2, where k is equal to 6. Okay, if you want any more practice, if you go onto the Durham Learning Gateway, onto the student section, numeracy, key stage 4, into the folder that says GCSE past papers, there is a folder in there which says GCSE topic papers, and there is an exam paper full of Pythagoras theorem questions which you can use to get a bit more practice.